everyone. Welcome to the lab session on working with log returns. So in this example, we're going to look at the Google's stock data. So we use the Y Finance package to download the stock data for this range, from the 1st to the 8th of January. Of course, not every day is a trading day. So in this case, we get 4 days of data. Now we have the dates as an index, and we have 6 columns here. So we're going to work with the, for example, the close column, which indicates the closing price, and illustrates how to calculate the log returns. So as mentioned earlier, we have the utility function, which is called the percentage change, which means that we can pass in the series, a Python series, and then it will we can apply the method under the series and get a new series. So this new series shares the same index, but the result is it's calculated as the percentage difference. So for example, for this value, the percentage difference for the second day is calculated as taking the current second day's price minus the previous day, right? So it's the closing price minus the previous day divided by the previous day. So this means the percentage change compared to the previous trading day, right? And because the first day there's no prior price for comparison to take the difference, then it's shown a name. Right, so that gives us the percentage return or simple return, which we used to call. And these returns represents the daily returns. Right? Each day there's a different number. We can ask the question how to calculate the terminal return. Right, so the terminal return means that if I start with, for example, 89, this value at hand, and how much money will I get? What is the percentage change at the end of the trading period, which is the end of day 4, right? So I start with this money and I ended up with this amount. So of course, this is a drop in price, and I would like to know how much in percentage terms, in terms of change, did I experience? All right, so simply we just take the last, the terminal price, right? And then divide it by the initial price minus 1 to adjust it to the simple return format. So this gives us the 1 plus R return. Okay, so we have about negative 1.7%. So this is how we calculate the terminal return. Of course, there's another way to calculate the terminal return by viewing it as a sequential compounding process. So what this means is that we have different returns, simple returns in each day, right? So these are simple returns, and we would like to compound it day by day, so that it's actually following the process in terms of daily changes. And now, the way we go about this is we can take the returns, simple returns, and then convert it to 1 plus R format. So this represents the incremental changes. So we can just multiply this quantity to get the price, to get the wealth of each day, and in terms of the percentage changes, and then we can then call the cumulative product function. So cumulative means that for each day, I'm looking at each day, and its result is calculated as the product of all the previous quantities, including the current quantity, right? So it's a cumulative product for each trading day. So this gives me the cumulative product for each trading day, and then I adjust it back to the simple returns. So by minusing 1 here, then it gives me the cumulative returns for each day in simple return terms. So this is how it calculates the cumulative return. So the last quantity of the cumulative return which is extracted here, right? So by extracting the values property, we just take the quantity itself, right? So the quantity itself without the index. This is accessing the values. I will take the last value, and we're assessing if the last value is equal to the terminal return we calculated earlier, right? So it's just this amount is the same as the previous amount we calculated. All right, so that's the approach in terms of calculating the terminal return from a cumulative standpoint. Now we can also do the same thing using the log returns. So log returns works with the 1+r format. So which means we take the simple returns as a series and then +1 to convert it to the 1+r formatted return series, and then apply the logarithmic transformation. So this is just a transformation that takes the value mapped to the logarithm curve, and now we have the result here. So this is a transformed returns, which is called log returns. And the difference is really here, right? So previously we take the cumulative product. So this cumulative product is sometimes difficult to work with when deriving the mathematical terms. So instead of taking the product or taking the multiplication, we can apply the logarithmic transformations. We have log returns, and then change it to cumulative sum. So now multiplication became summation here, and it's still cumulative, right? So what this means is that for every period, every trading day, each term, the result is calculated by summing up. So this is sum, cumulative sum, all the previous quantities, including the current quantity, right? So cumulative sum. And then this gives us the log returns summation, and then we convert it back to the previous, the original 1+r format without the logarithmic transformation. So this is the inverse of the logarithmic function, which is exponential function, and this gives us the 1+r. So -1 means adjusting back to the simple returns. So let me just write something here. So here, before we have for example, for 2 trading days, the quantities are A and B. So we just multiply A and B. But now after we apply the logarithmic transformation, then what happens is that we have log A, and we can just transform change the previous multiplication. So this is a key here. So now this is a plus sign, right? So plus log B, right? And which gives us the log A and B based on the properties of the logarithmic function. And finally, we apply the exponential transformation. So exponential transformation here. Let me move. Okay. So exponential transformation, which cancels the logarithmic transformation, then it gets us back to actually we have exponential here, and then we have AB. So the A times B. So this is the same result as before. It's only we're taking a bit of a detour to going from log to exponential, which gives us to the original value. So let us check the results here. So we have the cumulative return 2 series, which is this value, and we're also same thing, taking the values of the series and then take the last entry, and it also equal to the previous terminal return we calculated. All right, so that's it for this video, and thanks for watching.